Good afternoon. Today's presentation is about the understanding of the movement of people and also the need for the understanding of this in conjunction with the development of a transport model when you're looking at a particular scenario. Transit development, or the movement of people by any form of public transport, allows a greater mobility for more people and offers decision makers the opportunity to restrict the use of private vehicles. But we think about urban transport, but what of regional or intercity travel? Should we not encourage the same principles in this type of movement? Today's presentation is divided into 6 sections: an understanding of the movement of people, a modeling overview, a look at the methodology and the forecasting procedure, followed by some examples, and then a recap of what we've done and learned hopefully today. Now, let's look at some things in perspective in the movement of people. Indian cities in perspective. We will use a transport model for the sizing of the system to look at technology. Today we have to, as transport planners and decision makers, consider compliance with green technology. And can we use a transport model to correctly understand the movement of people between various locations? Let's look at Indian cities in perspective. In 2020, we had 9 cities in India with populations greater than 5 million, 19 in the range of 2 to 5 million, but altogether 60 in the range of greater than 1 million. But how many of these cities have high capacity transit within or between the cities? Which city should have transit first? Now, this is something that we may be able to address if we have a transport model for these various cities. Let's look at a transit proposal. What would happen if we could link Mumbai, Hyderabad, Bangalore, and Chennai, a total of some 50 million people, with a high-speed rail? These are becoming ideal distances. Mumbai to Hyderabad, 700 kilometers. Hyderabad to Bangalore, 600 kilometers. Bangalore to Chennai, 350 kilometers. This could be an interesting situation if we had the transport model to understand it properly. We want to size our development. If we have a transit system, we want to size it. Urban space, as you can see, is a premium. If you look on the left-hand side, you see the cars needed to take this number of people, or the number of motorcycles in the center needed to take this number of people. Or finally, we see a bus. One bus can take the same number of people. So we want to look at the system sizing. And this is what can be helped with a public transport model. If in urban transit, we can run a transport of rail at 50 kilometers an hour. If we're using mass rapid transit, we can get up to 60,000 passengers per hour per direction. Now, what are the benefits? We look at the carbon emissions. If we're looking in comparison for high-speed rail, 4 kilograms of carbon dioxide per 100 passenger kilometers. Air is 17, as similar is the car. So we can move to a much more efficient and green technology if we use transit. But we have to understand how many people might be attracted to this. In Cairo, a mega city of the world with a population in excess of 20 million people, there is a transport model, and it was used for initial screening. But before there was a transit model or transport model for Cairo, we'd already drawn lines on a map which said this is where the transit line should go. But when we used our transport model and GIS techniques, we saw that this line was in the wrong place. So with mathematical techniques developed within the transport model, we could see that it was appropriate to change the alignment. So let's step back. Let's look at a modeling overview. Let's try to understand people movement, predictability, transit in a city. We'll have a brief look at Chennai, transit in a region. Where has high-speed rail been developed already? Transit in a city, transit, land development are interlinked. Transit means land cost improvement. In Bangkok, for example, as the existing elevated transit system was extended, before it was even open, adjacent to every station, once people knew where the station was, there was shopping centers or high-rise accommodation. In other words, the land development in that area was helped. So it pushes up the value of the real estate if you have transit in a city. And we can use a transport model to help us understand that. Now let's look at high-speed rail. When is it most appropriate? We see on the bottom x-axis here a distance of around 600 kilometers. This is high-speed rail. This is air. This is almost a break-even point. This is when you have about a 3-hour trip. And of course, when we think of high-speed rail against air, we can go to the center of a city and get on a train if the station is in the center of the city. But with a plane, we have to go to an airport, which is on the outskirts of a city normally, and then we have to wait maybe 1 or 2 hours for the plane. But with high-speed rail, we can do this almost immediately. Let's look at the potential impact of a high-speed rail. If we look at some of the original lines in the European situation, for example, Paris to Lyon or Madrid to Seville, about 500 kilometers separation in both cases. Air transport before high-speed rail was 30 to 40%, falling to 7 to 13%. Road was 29 to 44%, falling to 20 to 36%. If we build high-speed rail, do we still need to put lots of infrastructure in, especially to airports? We see here in this example, especially Paris to Lyon, one of the first routes in Europe. The air travel went from 31% to 7%, a very significant difference. Where has high-speed rail been developed? We see in Asia, we see it in Europe. In Asia, it's mainly been Japan, China, and Taiwan to date. And we see the network in Japan, for example, 2,400 kilometers. China, almost 10,000 kilometers. Taiwan, a small island, 350 kilometers. The average operational speed is 300 kilometers per hour. So we see there can be some big advantages, but in most of these cases, a transport model was developed to let people understand the importance and the impact of high-speed rail. Let's look at some methodology. A transport model, urban, an existing city, Colombo in Sri Lanka, a greenfield situation in Delhi extension from Huda city, in Amarati, adjacent to Vijayawada, another greenfield site. And we will look at what we started to use in the previous earlier slide when we looked at the example from Cairo, a megacity of the world. The model in perspective. We need to collect data to identify problems. We need to analyze the data. We need to make a plan. We need to forecast the impact of any plan with a model. We then need to evaluate the impact of the implementation. For example, we might want to understand the economic feasibility. We might have 4 or 5 transfer proposals in maybe one city or multiple cities. We can use an economic evaluation. The key outputs come from a transport model. In Colombo, we developed a light rail model. This is the center of Colombo, the fort area, and this was the depot out to the east of the main part of the city. One of the things the model was used for, we needed to know how many passengers per hour, per direction, would be using the system when it opened and maybe 10 to 20 years later. This enabled us to define the size of the system. Did we need a high capacity metro system, 60,000 passengers per hour per direction? Or did we need something smaller of the order of 20 to 30,000 passengers per hour per direction? So we could use maybe a lighter rail rather than the heavier rail system. But the model developed allowed us to also understand what happens with the fare. We don't want to charge too little and have too many people using the system. We don't want to charge too much and have very few people using the system. We want to have a rational fare. But when we are setting the fare, we must remember it is always, I repeat, always easier to decrease the fare for a period of time than increase the fare. If we set the fare at 20 units per kilometer and we discover this maybe is too low, very difficult for our decision makers who are above our transport planning fraternity to justify a significant increase in the fare. So the model will enable us to get a better understanding of the fare sensitivity. Many of you are aware of the wonderful metro system as it exists in Delhi. There was a project to develop a greenfield site south of an extension of the Delhi metro from Huda city to Bawal. This unfortunately did not materialize at this point in time, but the model gave us an idea of how and how many people would be attracted to such a system if it was developed and made to operate. In Amarati, which was a proposed new city adjacent to Vijayawada, we had the model was used to develop and test metro. We wanted to develop the existing city of Vijayawada here to the new city proposed of Amarati. We needed to test what type of system we might need. This was very important to understand, again, the sizing of the system. We wanted to use the model that we developed here to also locate the fare, to estimate the fare and look at the station locations. The model again here, this is the example we looked at before. This is Cairo, a mega city surrounded by desert. So the value of land is very important here. And we already had 2 metro lines, one running north-south, one running east-west. And the next metro line, we had to decide where it would go. And by using a transport model that was developed for Cairo, together with GIS techniques, we saw that it was important that the metro line go next in this direction, adjacent to higher populations and employment centers, rather than in this direction, where the population and employment was not so high. The importance is we always only have limited funds for expenditure. Thus, the model, when developed, can help us and guide us in the right direction. Now we want to look at forecasting procedure, the model structure, what is needed. We often have to collect data. Many places do not have a transport model, so we need to collect data to develop such a model. Just a couple of techniques and definitions that we might need as we look at the development. This is really respect to an urban transport model. In an urban transport model, people start from home. They walk to a bus stop. They walk from the bus stop to business. This is called a trip and is linked to the traditional 4-step transport model, which we'll see in a few minutes. Whereas this, people start from home, they end up at work. From work, they go back by walking to the bus stop, and eventually they end back at home. This is a different technique. This is called a tour, and this is linked to an activity-based model. The network that we might talk about is virtual and is the computerized road and public transportation system. You might say it is a digital twin of the reality. We look at the reality of a network, which is the road system, the transit system, and how we might travel by transit, or how we might travel by air, which is part of the network for long distance traffic. And then we put this into a digital system, which is a virtual and computer road and other public transport system, so that we can understand it. What do we need in the development of a transport model? If we have a city model, if we have sufficient funds, we would do a home interview survey. These are very expensive. A home interview survey in any major city, there will not be very much change out of $1 million US converted into local currency. We want to do traffic counts. We want to do travel speed surveys. We want to do inventory surveys. And we also need to collect demographic data at a small area or traffic zone basis. So often the demographic data is available from census information. Now this is a city model. We look at a regional model and we want to do traffic count surveys. We want to do roadside interview surveys. We may want to do sensitivity surveys. If we're looking at not only people, but cargo as well, then we need to do freight surveys. But for this presentation, we're concentrating on the movement of people at the city area and the regional or national area. So one particular survey that we can look at, which is used both in a city analysis and in a national or regional analysis, is the roadside interview survey, becoming more difficult in cities because we need the cooperation of law enforcement to actually stop vehicles. But with the vehicle stopping, we want to know the origin and destination of a trip, and we want to know that by a traffic zone. So we have to work out a way of being able to say, when people tell you where they're going from and going to, we have to then be able to put that into a digital format. In the development of roadside interview surveys, both national and citywide surveys, we would like to try and get and obtain a sample of around 10%. In the city basis, we would probably also use the origin destination survey to check on the results of any home interviews that we might have been able to do in the context of the movements within a city. In the case, this is an example of a high-speed survey that was done in looking at the potential travel between Yangon, the capital of Myanmar, and you might say the cultural or tourist center, Mandalay. Myanmar is quite unique in that it has these two major cities, which could be at either end of a railway link. But in the center, to make it even more attractive, we have Naypyidaw, the national administration's capital. Here, we wanted to understand in the surveys initially how many people would use the system. So we needed to understand the sensitivity of fare. Fare became very important. So we needed to know if people were prepared to move away from the use of, in Myanmar, for most people it's bus, but there's some people who use car. The existing train service or rail service is very slow, so people did not tend to use that between the two cities. We have different model structures, you might say. For a regional or national model you see on the left-hand side, where we look at total person trips, and we might split into high performance and non-high performance. High performance being air and high-speed rail. So these are the faster trips. Non-high performance being car, and then splitting into public transport. We would often look at this by economic clusters. So we would do the modal split for each economic cluster. In the case of this, which is an example of high-speed rail model from southern India, we did it in 3 economic clusters. The flowchart on the right is a city-wide model, which the structure of this included 3 income classes and 4 trip purposes, and we split the trips initially between non-motorized, in other words, walking or rickshaw, and motorized trips. And this was a structure of the initial transport model developed for another megacity, namely Jakarta. What does this, when we talk about modal split, it's worthwhile just spending a few minutes to understand that we are looking at if we can do 2 choices, and so it's a hierarchical model as we just saw, then we can use a logit model. And you might say the calibration of a logit model is very difficult, but if the probability and the cost can be structured correctly, then if we do a series of binary choices, then we can actually do a best fit linear regression, which of course linear regression is relatively easy. The techniques are well known, and it can be even done in a spreadsheet to estimate the parameters of this line. So even though the mathematics might look complex and complicated, we can break it down into some form such as this. Some examples. I want to share with you 2 examples. One, when we developed a transport model for the outskirts of Delhi, and another example when we developed a high-speed rail model in southern India. So this is Huda city, and this is Bawal. And so we were looking at developing a transit system here. But this was almost a green field at the time. This is about five years ago, if I remember correctly. And so it was difficult to understand what might happen when you actually had no people there at that particular point in time. So with a greenfield site, we looked at having to do surveys to understand the movement of people, and then we had to also look at where we might have the major centers for our station locations. So we did a small survey at many points along the potential route, where we interviewed 2-wheeler vehicles, 700 of them, cars, 600 of them, buses, 500, auto rickshaws, and any existing rail transit. So in the survey form that we wanted to talk to people about, we asked them personal data, their education level, occupation, monthly income, number of household vehicles. That might seem a strange question, but household vehicles also give us an idea of the income of household. People often don't want to discuss their income, but they're quite proud to tell you how many vehicles are in their household. So we wanted to understand the next part was the trip data, how people are traveling at the moment. And then the third part of the survey that we asked people was whether they were prepared to pay additional amounts of money for better for better comfort, and whether they were prepared to pay for time saving as well. And this became the structure of the transport model that we used to understand this process. Our projections from this transport model suggested that we would get a reasonable amount of transit here after opening. This was an earlier Indian proposal for high-speed rail, some 6 to 7 routes depending how you split them up. It was Vision 2020 of Indian Railways. They envisaged a high-speed rail with commercial speeds above 300 kph to cater for intercity travels. This was an earlier proposal. We are going to look at what was developed as a transport model for the southern understanding of high-speed rail. The objective of the Ministry of Railways was to look at the 7 identified corridors. Some were split into 2. This is our example that we're looking at. Chennai through Mysore to Ernakulam to Rantrapan. So the total distance from Chennai through here is 1,000 kilometers. But we have large cities here, we have large cities here, we have large cities here, and we have large cities here. So one of the things that was looked at was, if we build high-speed rail in this region of India, what do we need to do as far as the development of other transport infrastructure? Do we still need to make a mega airport at Chennai? Or a mega airport at Bangalore? Can these be considered as alternatives to high-speed rail? Again, we needed to do surveys here in the development of our mode split equations. So once more, we asked personal information about car ownership, the number of people in the household. Then we went into and asked people about their trip information, how much they pay for a trip, the trip frequency, what mode that they were currently use. Then we went on to a stated preference sample, whereby we tried to understand, if we charge a certain amount of money, would people use our high-speed railway system? So the existing mode split in the corridor was 11% to air and then 18% to car. So we wanted to see if we could change that. And that became the reason why we wanted to develop a transport model. And we look at these 3 states in southern India, we see that these are big states. There's a large population here. So there is a potential demand for travel between these 3 states. And this is where we developed the high-speed rail transport model, as we saw a few minutes ago. And we developed it into 3 income classes. And we used 2 trip purposes, what we call discretionary and non-discretionary. Discretionary meant you didn't really have to travel. It was for personal business or tourism, but the non-discretionary trip was you must travel. In other words, basically related to the work system. The key inputs into the modal split analysis were travel time and cost. And the travel times that we looked at were, if we went travel by rail from Chennai to Hyderabad, for example, it was 13 hours. If we travel by bus, it was 17 hours. But if we travel by high-speed rail, it was almost 3.5 hours. And this compared to nearly 3 hours with air. So high-speed rail was faster for every mode except air, but it was compatible with the amount of time that was spent traveling by air. And we see here that we could use the model to obtain the maximum fare, which this is revenue against fare. And so this is what the model was used for. 3 different fare classes as well. So we knew the revenue and we knew the number of people that were traveling. So the patronage and revenue forecast. As a sideline, we developed a very good GIS mapping base for the network. So we looked also at a very important issue which we were able to address with the development of the transport model. Where would the station be? For example, would it be in Chennai Central or would it be on the outskirts of the city? And the model was able to address the issue of ticket pricing so that we could look at what the optimum ticket pricing should be related to revenue, but also what the optimal ticket pricing would be linked as far as economic evaluation is concerned. So what I've tried to do in this presentation today is look at the movement of people. We've looked at models and methodology and forecasting procedures, and then we've looked at some examples. So I hope the presentation has been enlightening, and I would like to say thank you for your time. And of course, if you have any questions, please feel free to ask at the appropriate time. There's a list of references attached to this presentation for anyone who's interested in it. All the views expressed in this presentation are the views of the presenter and do not reflect views of any government that was mentioned in this presentation. So thank you once again for your time, and I hope that the presentation has been enjoyable. Thank you.